Can you
Please.
see my screen?
No, Rose on top. Rose, share the screen.
Yeah, I've already done that, but I'm not sure whether you can see it.
Have you given the permission?
Yeah.
You have given this.
Can you see my screen now, sir?
Yes, no. Now we have given the grant. Check that one. Share the screen. You know there is
Okay.
an arrow. You can't see your screen.
How about now?
No, it is still not. Yeah, yeah, we can see your face.
Okay. I'm trying to.
You know how to share it?
Yeah, that's. I guess it's coming up now.
Yeah, yeah, coming up. Yes, yes, yes. Go ahead.
Okay.
You know Adam Optimizer.
All right.
Please. You know Adam is
So,
also present here.
okay, sir. I can start now. Good afternoon.
Good
I'm Rose.
afternoon.
I'm Rosalie Oluwaseun Ogudokun from.
Go to the introduction directly.
All right, sir. This is my presentation outline, and I'm trying to. In this work, we were able to work on image classification, and we
Change
noticed that.
the slides. Change the slides. Slides are not changing. Make it full screen.
It's already full screen.
No, but here not.
Wow.
If I may,
Yes.
Rosalind,
Go ahead, whatever you.
can you start
Yes.
slideshow maybe?
Yeah, maybe in slideshow mode. Where is your wife, man? Let me see.
What about now? How about now? Is it full now?
It is not full. You can go ahead, please. No
Okay.
problem.
So we noticed that. Wow.
It is again gone.
Sorry, the slide closed. I was interrupted with the slide closing, so I have to reopen it. Okay.
See?
So God. Sorry, can the other person continue? My slide has scattered. I don't know what is happening.
Just to close it and again open it.
Yeah.
Where you went? Sit down here on front so everybody can see.
I don't know what happened that
Don't worry, be patient and
I
open
think,
it.
yeah, it's scattered. I think I have to arrange it again. Let me just go off and come back, sir. I don't know.
Chair, what is your opinion? What to do?
I think you have to try to share the screen again because
Yes, my PowerPoint scattered. I don't
uh,
know what
if you
happened.
can spend a
So,
minute, try to export your PowerPoint to PDF and share
okay,
PDF.
all right.
But we still can't see your screen. You're not sharing.
Yes, okay. I'm trying to. The PowerPoint I was supposed to use for the presentation, it's scattered. So I'm trying to arrange it again. That's what is delaying me. And I don't know what went wrong.
But are you sharing right now?
No, I'm not. I've stopped
Okay.
sharing. Just give me some few minutes. I'm almost done. I think I will just have to manage that like that. Let me just manage it like this. Can you see my screen now?
Maybe gradually with time, yes, something is changing.
I'll just manage it like this. So the topic is improve CNN based on batch normalization and Adam optimizer. From literature review, it was noticed that CNN has gained a lot of touch in image classification, and due to that, it got a lot of consideration in object detection. That is also for image classification. But CNN came with different difficulty. There are some difficulty that I'm faced with using CNN for classification. Some of the difficulty we tried to improve. We tried to improve some of the problems that we faced with CNN method by introducing batch normalization, dropout, and also Adam optimizer. So the problem that we encounter, some of the problems that we encounter with CNN is model overfitting, increased computational time, small data sets. So the objective of this study was to introduce batch normalization dropout to overcome the issue of overfitting, and also Adam optimizer to assist in the computational time of the model. So the data set that was used for this study was Cypher 10, which has 60,000 images. 50,000 of the images were for training, and then 10,000 was for the testing data set. And then data sets had then 10 classes. And the two model, we use CNN alone without introducing the batch normalization and dropout. But the optimizer was used. Then the CNN was used alone with the optimizer, and then we compared the performance between the
Those
two.
slide is not changing.
Sir?
Those slides are not changing.
Yeah, we see only the first slide.
Wow.
Rosalind, I have a
Yeah.
question. Do you have two screens or one?
I have only one screen. I don't understand what is happening.
Yes, it is now okay.
I have only one screen.
Good, but now we see number 6, so you can change it manually. It's okay.
Go ahead. That's why we say that share the screen, but it is not share the screen. There are only PPTs you are going to next PPTs. So it is internet.
Okay, how about now?
Let it come. I can see several screens of yours. Why you are not doing in the share screen from bottom? Yes, click it.
Yeah, I have. I can see two options. One is entire. I don't even. But presently, I'm sharing the screen now. I don't know whether you can see my screen.
Okay. Okay, go ahead. Anyhow.
Okay.
Yes, it is now in perfect order. Yes, it is moving as.
Okay. All right. Thank you, sir. So, do I have to go back?
No,
Do
it's
I need to
fine.
go back? I should just
No,
continue.
no, it's fine. Just continue. It looks good.
All right.
I have not.
So this is the proposed system flow. We load the data set, then the processing was done by normalizing and resizing the data set. Then the data set was splitted into 80-20. That was the ratio that was used. 80 for the training and also 20 for the testing phase. Then the two algorithms were used, CNN with normal optimizer, then introduction of batch normalization and drop out was used with the CNN algorithm. Then the classification of the cipher data set, and then the system was evaluated. The performance of the system was evaluated. Now, this is the parameter that was used, that was set and used for the implementation of the work. The EPOBs was 50, batch size 32, validation split, that is 20, then the training was 80. Then the optimizer learning rate was 0.001, and then the loss was categorical cross entropy. Then this is the graph, the graph for the improved CNN. That is the CNN that used batch normalization and dropout. We have the accuracy, the model accuracy, and also the model loss. And this is also the for CNN. We have the model accuracy and also the model loss. This is the performance evaluation of the two algorithms using CNN and also the proposed method. It was seen that the proposed method, um, the accuracy performed better than the actual CNN. Also, in the training loss, it performed better than the actual CNN, having the training loss was 0.89, which is lesser than the actual CNN, which had 1.41. And also, the training accuracy was 0.69, while being compared to the actual CNN having 0.49. And then the validation loss was also lower than the actual CNN. The accuracy of the validation was also higher than the actual CNN. Then the testing accuracy was also the same. So it was seen that the proposed system performed better than the actual CNN. So the main contribution to the knowledge is actually introducing batch optimization to minimize overfitting and to increase the generalization. It's also helped the model converge rapidly, reducing training time. Then the dropout that was introduced was 0.2, and it was introduced to assist to prevent overfitting by randomly setting an input unit with a frequency rate of each step during the training period. Then Adam optimization technique was used to make the model more computationally efficient, as well as to optimize the model with big data and parameters. So in conclusion, this study looks at the architecture of CNN. The overfitting issue was issued out and was solved using dropout layers and batch normalization, and also optimizer, and also Adam optimizer with CNN. So in the future, it is proposed that we can try to improve the accuracy, the training and the validation accuracy, and reduce the loss by introducing batch data augmentation. We can also introduce hyperparameter tuning to also assist in the higher accuracy for both training and validation. Then other algorithms can be other algorithms like transfer learning algorithms, transformers. They can also be used to get a better classification results. Thank you for this. These are my references. Thank you for listening.
Very nice presentation. Ruslan, go ahead. You are here.
Just a couple of questions. I'm just curious. For example, dropout rate of 0.2.
Sorry.
Was it empirical number, or you just picked? Did you experiment with something else?
I just tried with 0.2, although I didn't really try another dropout value. But
Okay,
in future work, we can try that and compare the
and the
performance.
same with the learning rate. It was 0.0001. Did you try
Yeah.
to experiment with different
No,
degrees
that
of
was why I
standard?
said no. That was why I said we can try to use. We can try to introduce hyperparameter tuning to, by introducing hyperparameter tuning, we'll be able to suggest other learning rates, and then it automatically pick which one performs best. Then we can use that for our model experimentation. So, but for this work, we only use that learning rate. We didn't compare. We didn't use another one to compare with it. We propose that for future work.
Well, it looks very interesting and promising. I assume you don't have unlimited computational resources. Otherwise, it would be interesting to try the same experiments with ImageNet.
I do for now because the system that I'm using is not too. Sometimes when the code is running, it's shut down the kernel and the likes. And then sometimes when I'm using Google on the Google Colab, it crashes because it's limited. So it's only if I'm thinking of subscribing for the premium so that it will assist in the computational experiments.
Oh, that will be interesting. Thank you very much, Rosalie.
Thank you.
Very good presentation. Thank you.
Yes, Ruslan, go for the next. Why you are stopping? You are chair.
I am just checking. I'm not sure. Do we have Adam, Erica?
Yes, Adam is present physically here.
Oh,
So
okay.
you
Good. Thanks, Adam. Welcome.
So, yes,
Yes,
yeah,
it is 3:20, right?
okay.
And you can run the PDF. One minute. No.
Thank you.
Ubuntu. Yeah, Ubuntu. The PDF should be, yeah. Yeah. Okay, yeah, thank you. Yeah. Okay, so thank you, first of all, the organizers for accepting our paper to this high visible conference. And it's my pleasure to present the paper. Title is here, so the application of single input, single output networks to forecast selected items in financial quarterly reports. This paper presents, let me say, not the result, but the application of tools with pure parameter to show and to check how it could be this technique could be applied to forecast some discrete data, but this discrete data are given only in a very rare period of time. Yes, so we are dealing here with quarterly reports, so the data are visible in each quarter. We, in our research, we are trying to combine this data with other sets of data that are connected with generally the stock exchange data, so the data with high frequency. But in this paper, we are just focused on the selected items of this very rare data from quarterly reports. So generally, the project is about within the project we built a system to support the decisions of individual customers that are playing on the Warsaw Stock Exchange. So within this project, I do not mention the set of authors. Dr. Katarzyna Klimczak and Dr. Tomasz Krzyński are our experts on from the Warsaw Stock Exchange, and we are cooperating. Yes, so we are cooperating, and here. On the first slide, it is just the front page of the Warsaw Stock Exchange website, but usually we are dealing with the data that of the rather high frequency. So the examples are the tick data, so the data of very high frequency, then there could be a 1 minute, 15 minutes, and once a day data. Usually we work with them, and this is the high recognizable, the share price of the financial instruments. It is what we the most often deal. But also we made in our analysis the data with different discretization time. So here there is an example of so-called investor sentiment index. This investor sentiment index is given within 1 week. So each week we have a new data. Yes? So we're comparing this higher frequency data with such discretization time in 1 week. Also, it is a challenge how to combine this data to produce a useful tool, yes, for forecasts or predictions. The other set of data, we are mainly focused on that, presented here, are quarterly data. So this set, the number of financial data is more or less, so the size of each column here, so the size of the vector of financial items is about 300. It is published 1 per 3 months, quarterly data. But so very rare, yes, very rare. But if we are focused on the additional information like the date and time of publication of this data, we see that here we have minutes and seconds of the publishing this data, and also the differences in seconds could influence the market behavior. Yes, so we are also trying to deal with such things. So generally, as I said, the project combines all these things. Let me skip some slides, just describing the project. And here a short summary, the types of data. So we have the very high, the data of very high, medium, low, and very low frequencies. The examples were shown earlier. And generally, the form of the data could be also different. Yes, like text data, numerical data, logical, categorical, and so on and so on. So the general idea is to propose a system that is able to combine these data to a better predictions. But generally, we are not focused on prediction, for instance, of the future share prices or something like that, since the stock exchange is accumulating and building the data, the database for all instruments that are present on the market. So it could not be focused and suggest investors to do particular decisions. Yes. So this forecast analysis will be, in our case, is rather used to indicate a possible sources of anomalies or unexpected behavior of some financial instruments and other non-typical behavior, not suggesting which instrument I should buy or which instrument I should sell. Yes, it is a task for, let me say, a high frequency automatic trading, high frequency trading, or AI supported trading. So here we are focused on selected items in these financial quarterly reports. They are shown here, like revenues from sales, operating profit, loss, net profit, and so on and so on. Yes, we gave the real data from the market thanks to our experts and check the possibility of forecasting strategies. So generally, the methodology is to forecast the behavior, the values of these selected items, some steps ahead. In the future, we use in our analysis the toolbox that is included in MATLAB package, but we tuned the parameters of the learning, of course, in such a way to optimize the result. So the general schema of the algorithm used for this analysis is classical, is presented on the left. So we define the network, we teach the network, we set predictions, and so on and so on and so on. Since data in this financial report are of different scales and of different nature, we need to normalize them using different normalized techniques to be able to compare the results. We here show just our one choice without further justification. What else? We need to deal with the missing data that are present in financial reports. It could look surprisingly that such formal requirements are not always fulfilled, but it is the reality. When we obtain the data, in many cases, we meet just the missed data, and this missed data should be replaced for some to be able to perform the analysis, the forecast, and to run the simulations. Okay, here we show 3 different cases. In first case, it is the selected item as a, let me say, complete data. So each value is known. We see here some strange, for instance, behavior like jumping one of the parameter through this quarterly report. Please note that each dot is connected to a quarter. Yes, so the number of 50 quarters is about 10 years, something like And forecasts, we see that just taking single input, single output means the prognosis based on only this instrument. We missed here this selections, the error that is presented, normalized error that's presented on the right, also yeah, as the values that are of course not satisfactory. And also it could be visible on our cases. It means that this prediction is generally not accurate. The predictions are not accurate, but it is more very often it is enough to indicate the anomaly situations. Yes, so it means that the value presented in the next report is acceptable, or we need some warning that we should think whether something is wrong, maybe from the formal point of view of the report, or some information could be not clearly visible. So here the second thing is the case when we have slightly incomplete data, like at the beginning, but generally it does not influence the future predictions because of this history. The third case we shown here, it is the case where we have more incomplete data. So this incompleteness represented here by the red dots, we see that through the whole horizon of our analysis, we meet many empty spaces. They are filled with empty spaces, and we have some, and as a result, we have some predictions. Then what we mentioned earlier, we need the problem of combining the data with different, let me say, sampling time, taking the vocabulary from the discrete time systems. So we also additionally check what is the influence of presenting the quarterly report item with the evolution of the price share until the next report is published. That is why in this table we see the 3 columns. So 1 month after report is published, second and third month, the evolution and how it is connected with the values and the cross-checking the influence of this data, this historical data on the behavior of the price share. And we indicated that such similarities could be found. So some financial items are strongly correlated with the future behavior of the share price evolution. Of course, it cannot be an accurate prognosis and accurate analysis, since on the real market, on our market, as an each market, we need many external signals that influences the behavior of the market. Yes, so that is why the analysis here is treated only, should be treated only as a supporting tool. So the forecast result in financial report case should be treated rather as a supporting tool in automatically noting possible unusual changes in financial data reporting than an efficient forecasting tool. But as we said, the stock exchange cannot suggest to investors their behavior. They just give the tool for the analysis. So summarizing, we built a supporting tool, using the classical networks to the data with different sampling time. Thank you. Okay, that's it.
Can you see some of them?
Yes, I did. Unfortunately, Jitsi turned off the video. I'm not sure. Hello,
Hello?
can you hear me?
Yes.
Yes,
Can you hear me?
yes, we can hear you.
Yes. Yes. In the middle of this show, Jitsi has turned the video off to save bandwidth. So I'm not sure is it just me or everybody who is virtually here. So I couldn't see the slides. But yeah, what I heard was interesting. I can just ask maybe one question to Adam without
Yes.
seeing the
Transport
slides.
inclusive.
Uh, did you try the like real world validation on the actual stock exchange with working broker just to hear their opinion?
You know, we have the source, the original source from the Warsaw Stock Exchange. And we do not use the external data since external data in other sources are delayed comparing to this our original source. Yes. So we were working on the, let me say, real-time data, but the results cannot be directly published since like each stock market earns money on selling the data. Its time of delay greater, so lower time of delay in this data causes that the price is higher. And our goal within this project is supporting tool for this Warsaw Stock Exchange. So we have only the original data. Yes, we only with the data. We do not use other sources that could be found. There are a lot of technical analysis tool, financial analysis tool, and so on and so on. Yes, available on market. They are some of them are free in some demonstrating limited versions, but we do not use the source, external sources.
Okay. And yeah, just maybe a small one. Before you tried LSTM, did you try to experiment with other architectures, maybe RNN or something?
Generally, yes, because you know it is a classical. It was here the classical tool for predictions we showed here, but in our model, the general system developed, we treat this rare available data. We introduce them into the model with higher frequency data as an impulse disturbances. Something like in dynamical systems, we have like Dirac impulses, yes, Dirac noises. So we treat, for instance, here in this quarterly report, the data that are published each 3 years are something like external impulse noise. Yes? And we check whether such technique improves the forecasting. Yeah? In some cases it improves, but in some cases this noise is, has no any influence on the accuracy.
Yes.
Oh, thank you very much.
Thank you.
Go ahead, Ruslan.
I still can't see anything.
So it
I will
seems
try to log on again. I'm not sure.
No, he has seen the presentation. Have you seen the presentation, Ruslan? Yes.
No, just part of it. And then now I'm looking at the blank screen mostly.
That's not good.
Okay.
So I could only hear what was there.
It's okay. So
But
I think
let me try to log out and log on again. I'll be right back.
okay, but I think the next session is at 4:20, right? At what time? Just to check it. It is 4:20. After 40 minutes, because the last presentation is not there. The guy is not here, right? So I think our next is in the is the first author. I think they should because they are from Hungary. This is the last.
Yeah.
420. Let me check. Daniel. Okay, they are here. I think. Jawal, Mehmet
Okay.
Akhtar will also present. Mehmet Akhtar. So
Video.
all presentations were there. These guys are physically present, and these two. Thank you so much.
Thank you.
Okay,
Thank you.
you are welcome. Yes, yes, give him the contract.
Can I?
So this is the tea break, right?
Pardon?
It is a tea break.
Yeah. But we have.
Can I take?
Yes. Now you.
Okay.
Ruslan, thank you. I hope that you will be here. Ruslan,
420.
Ruslan,
I'm trying. Hold on a second. My video is
I'm saying that,
gone again.
yeah, I hope that you are coming back on 420.
Okay, so the last presenters are not there, right?
No, he is not there, yes.
Okay. Yes, as I said, I'll come help you out. 420, same room.
Yes, 420. All the three presenters are there in 420 slides. The first one is
Okay.
the physical presentation, and the two from Turkey, from Mehmet Aktash, they were online presentations. Right? So see you at 420. Thank you so much,
See you.
Ruslan.
Thank you, Sanjay.
Let us go for a tea. Let us go for a tea. You can leave the bag here as well. Can we leave the bags here?
Pardon?
Bag can
Yeah,
we?
you can.
For you, there's a general scientific from elsewhere, yes. Scientific approval. It is in Scopus and Science, which is very good for you.
I was on the other gypsy session on this. Hi.
So I'm the first presenter.
Okay. Do you want to prepare the? Okay. Let's wait some 2 minutes because there was people that will come right now, and also the chair didn't appear.
Welcome. So, okay, this is the first presentation. Is everybody connected? Anybody else from outside? Live streaming? Yes. Good afternoon, everybody. Ruslan, nice to see you. So, we have a presentation from the author who is physically present. It is very nice. So let us introduce him, and he is going to make the first presentation. Efficient GitHub crawling using the GraphQL API. Your name is
Daniel.
Daniel. Is okay. And he will present. Ruslan, the floor is yours. If you want to say something, we have some audience as well. Due to him, he is from Germany and he is going to present the paper. Right? Floor is yours.
Oh, thank you, Sanjay.
One second, please. Yeah.
Yeah, thank you, Sanjay. Welcome. My name is Daniel Atzberger, and today I will present you our work, efficient GitHub crawling using the GraphQL API. Yeah, our work lies in the area of software analytics, and I wanted to show you one quote that gives you an idea of what this is about by Zhang et al. He says, software analytics aims to obtain insightful and actionable information from software artifacts that help practitioners accomplish tasks related to software development, systems, and users. When you read this definition, one has to ask, what are these software artifacts that you want to get some information from? On this picture, you can see an illustration of a prototypical software development process. In the first stage, the customer, together with some domain expert, describe requirements and store them in requirement documents. In a second stage, these requirements are translated into issues and stored within an issue tracking system. And then a developer grabs a ticket and tries to implement the functionality described in the issue, which is then stored in the version control system. After the DevOps phase, the software can be delivered to the customer. And you see across every stage, different documents appear. So data is generated that you want to get insights about. And this is often done using machine learning techniques. And when you use machine learning techniques, you often need training data. And that's our motivation for investigating GitHub. GitHub is the world's largest social coding platform with more than 83 million developers. But this number is increasing steadily, very fast. I guess 1 year ago, it has been 73 million. And many very popular projects are hosted there. For example, TensorFlow or PyTorch, so Bitcoin and other cryptocurrencies. And in our work, we proposed a system we call Prometheus that is built to crawl data from GitHub. And we named it after this ancient Prometheus, this myth, the figure who stole the fire from the Greek gods. So he brought some technology to the people. Unfortunately, he had a bad ending. So at the moment, we are fine with our Prometheus system. Here, I want to show you one application example, how you can apply machine learning techniques to gain information from GitHub projects. We investigated the vocabulary in source code files, in the comments and the identifier names, using some NLP techniques named labeled dereference allocation and its variants. And this results in the characteristic vocabulary associated to higher level concepts like machine learning or cryptocurrency. For example, in the cryptocurrency, words like order, crypto, price, finance, they are very strongly associated with this concept. This allows you to locate concepts within large software ecosystems, or if you apply to the commit history, you can locate knowledge among developers. We were not the first to build a system to crawl GitHub. We were mainly inspired by 3 works. First one, Sorcerer, proposed by Lindstedt et al. 2009, who focused on the actual source code and also applied LDA on it. Second one, very popular, is the GitHub Torrent project by Koisius and Spinellis, and they monitor the entire GitHub public event timeline. And the third one is the project BOA, proposed by Dyer et al., that allow you to do some high-level investigations of GitHub projects. And our system, Prometheus, was inspired by all of them. Here you can see some architecture image. No, it's fine. Our system follows an event-driven microservice architecture. That means that it's built up on small services that are mainly independent among each other. Especially we have two, the fetcher and the importer. The fetcher calls data from GitHub using this novel GraphQL API, and the importer receives this result and stores it in a relational database management system. So as I told you right now, we apply the novel GitHub API, the GraphQL API. Why is this useful? Well, in GitHub, data is stored in different entities, users, repositories, organizations, and they all come with different attributes. For example, each user has some associated avatar URL or some associated email. And these entities have relations among each other, thus forming a graph structure, which motivated GitHub and Microsoft. So Microsoft bought GitHub several years ago to apply a GraphQL API instead of a REST API. Now our GitHub fetcher is the component that receives some query from the user and translates it in a GraphQL API, as you can see in the picture, and it receives the results from GitHub. So here is a nested query. And then our importer receives this data and stores it in a relational database management system. Yeah, and both components communicate using some event backbone via an event-driven architecture style. To say something about our technologies used for the event backbone, we applied Redis. Alternatives would be Kafka, but at the moment it's not required to use such a big system as Kafka, so we were happy with Redis. For our relational database management system, we choose MySQL, and the entire program is written in Python. Each bounded box presents one component that we run on a single Docker. Yeah, the most popular GitHub crawler is the open source project GitHub crawler proposed by Microsoft. It is based on the REST API, so the version 3 API. In contrast to the V4 API, you have a very strong low rate limit. You have, I guess, 50 requests per hour and per token. And with the novel API, you have 1,000 requests each hour, which means that you can crawl more data based on the assumption that you implemented it correctly. And then our experiments show that the GraphQL API on GitHub is able to catch more data faster. In this experiment, this was our most simple experiment, we tried to crawl all issues of the project Angular. And our system Prometheus was faster by a factor of 3.5 than the GitHub crawler by Microsoft, which is not maintained anymore. To summarize, we proposed a system called Prometheus for crawling data from public GitHub repositories, and it makes use of the GraphQL API. And internally, we proposed a mechanism for crawling nested GraphQL queries. Our results show that the GraphQL API has advantage in terms of performance, as we saw in our experiments. But however, in some special cases, the GraphQL API has a lot overload. So in many cases, you crawl each node very often, thus resulting in a lower performance. We want to address this issue in our future work, especially by implementing concurrent API calls and a more flexible splitting approach to eliminate redundant queries. Yeah. If you have any questions, you can either ask or contact us via our emails.
Thank you so much. So, Ruslan, please offer
I
to
don't.
the others and after then yourself, and then
I don't have any questions. Actually, it's a interesting topic and interesting implementation. Would like to look at the paper when it's published, but for now it looks, yeah, very interesting. No questions. Thank you.
from the authors, you can invite to the authors. Okay, well, so what are you exactly you want to do it in here? It means as a novelty, because you mentioned that already that some authors they have started working from 2009, right? 2009, then 2014, and after then you are working. You are the third one, or more authors have worked similar work?
I mean, various authors are proposing systems to catch GitHub data. What makes our work different are, I would say, two things. First of all, our system is able to catch all data on GitHub. For example, this work from 2009 is only focused on the source code.
Okay.
But GitHub provides you also issues and metadata and data about authors, so everything. And the second one that makes our work special is that we are faster in terms of performance, as we are making use of this novel GraphQL API from GitHub.
Okay. So, but if you see the other systems, are you sure? Have you done any comparison? Have you demonstrated any comparison here?
Yeah, we compared our approach with the GitHub.
Can you show me the slides? Yes. So. Okay, so this is the two ones which you have compared, right?
Yes, the GitHub crawler from Microsoft is the most widely used one. That's why we compared against them.
Yeah, okay.
And it's based on this older version of the API.
Okay.
And it provides the same functionality as our system. That's why we choose to compare against them.
Compare against them. Okay. So that system was very close to your system.
Yeah.
That's why. And even though your system is performing better, right?
Yeah.
So what is your suggestion? What is your suggestions to the researchers or the community or industry that your system should be adopted, or you are still working to improve the system?
Yeah, right now we want to improve our system, especially with the more flexible way to split GraphQL queries.
Okay.
Because
so this is your future work.
Yeah.
You have included as a future work, right?
Yeah.
Okay. So it's means this is one of very rare papers which are in deep software engineering, right? Very close to that one. And it is a good presentation. You did a good job. So I hope that once you are present improving, next year again in the same conference you are going to present the next version of your system. Am I right? Okay, good. So give me a clap and very nice presentation. Ruslan, call to the second presenter.
Hi, everybody, and welcome to my presentation. My name is Pınar Koşan, and I am a software
Is the second
engineer
presenter?
at Technology. Can you hear me? Hello?
I can hear you at least.
Okay. And I'm also a graduate student at Yıldız Technical University. The topic of my presentation is a novel approach to a recommendation system with business workflows.
But you are the Pinar, right? Are you the Pinar?
Yes.
Yeah. Please go ahead.
Okay, this is the plan of my presentation. First of all, I will talk about importance and aim of the study, second, data set and methods, third, findings and tests, and finally, I will tell you results.
Everything is gone, my dear. Don't play with it. Where is this?
Oh,
Importance and aim of the study. This document uses the
mean,
power of
you
recommendation
lost the
algorithms
light?
and consolidated
no,
customer profiles to
sorry.
provide
So
recommendation
please
based on
split with them as
customer
well.
data.
I
In
was looking
addition,
the YouTube
performance
streaming.
of these algorithms was measured. Customer interaction on the site has a huge impact on the performance of AI methods. One of the important features is the similar users really have the same preferences. One of the most important obstacles to the implementation of recommendation engines for e-commerce sites is the lack of interaction of a user with the site products. A new workflow that can use different recommendation algorithms and generate recommendation based on implicit feedback methodology has been explored. To understand the utility and benefits of this workflow, we implemented a prototype and conducted an experimental study to determine the effectiveness of this prototype. In the study, customer features of a book size site were monitored. The features are as follows: user cookie ID, book item ID, and rating. While this project, we gathered these features from the website, and we used four AI algorithms, DNN, alternative list square, user-based collaborating filtering, and item-based collaborating filtering. After the method selection, the cookie ID should be selected, then press the display recommendation buttons. This is our interface. We select cookie ID and then we press the display recommendation. And we can see two separate listings were made for each method. One of them previously visited products and recommendation results according to chosen method. We show 5 recommendation this table. When we measure the performance of all methods by selecting the same user, the result is as follows. ALS recommended books, DNN recommended books, user-based collaborating filtering, and item-based collaborating filtering. DNN algorithms gives the best recommendation result because it's seen that this algorithm gives the close result to 1. We decide N, C, G, and HR values. This study designed a novel approach by implementing a hybrid recommendation system for a book commerce website by integrating classical collaborating filtering and deep neural network-based methods. Since explicit feedbacks is often unavailable for items, our data consisted of a preprocessed user item matrix of binary implicit feedback. Our implemented models include item-based collaborating filtering, user-based collaborating filtering, alternatively square matrix factorization, and deep neural network-based approach. Our item-based and user-based collaborative filtering, Apache Spark, and deep neural network is implemented using Keras, Tenor. We also evaluated the performance of the recommendation algorithms by calculating the average hit rate, NDCG. We concluded that the deep neural network-based approach had the best result among all other implementations. Thanks for listening. Do you have any questions?
I just got a quick question. How did you do the validation of your algorithm? Was it some practical setting? Was it on a specific e-commerce platform or?
E-commerce book sales sites. Our product is book.
Is it universal algorithm or it is very specific with books to do?
Yes. But we can use all recommendation system, for example, social media, e-commerce, new channel.
Yes, thank you.
Yes, Pinar, I have some question. What is your major contribution in this work?
I can't understand.
What is your major achievement in this work? You understand what is your major
NDCG and HR. We decide two metric. NDCG is, for example, N is hyperparameter for algorithm. We use 10. HR checks if the result is in the first N. NDCG, it scores high points for the top ranked ones.
Can you show the slide?
I can't hear you.
No, show it. Change the screen. I don't need it. I want to see it.
Pinar, can you hear me?
Yes, I can hear you.
Can you go back to the slides where you show the design of your architecture? Okay. Yeah, just stay here, Misra. So maybe I can answer your question. So basically, in this study, we worked on different algorithms that focus on recommendation on the log data obtained from a book e-commerce website. And particularly, we focused on the deep neural network algorithm that was different than classical recommendation algorithms. And what we try to do, we also try to integrate the results that comes from these different algorithms, and if they agree on certain results, so we wanted to show the agreed results that comes from different algorithms to the user. So basically,
I understand. You have applied additional ones. Hello.
can you repeat again?
Yeah, it's okay. It's okay. So thank you so much. Pinar has presented. But the next author is Ruslan. Please, can you announce and check? Fatma is there, right? So Fatma
Yes,
is present.
Fatma is my student and she is there.
I know,
Fatma just
I know. They both paper belongs to you. I know. An approach to business workflow software architecture. So Fatma, please go ahead. 10 minutes. Ruslan, if you have any question or anything,
No, not so far. But Sanjay, I think there's echo when you're speaking. Do you have two devices at the same
okay,
time?
I'm closing it in the last one. Okay.
Sorry, it is now you can hear me, right?
Fatma, can you turn on your microphone?
Yes, I on it.
Can you hear me clearly?
Yes, please go ahead.
Yes, thank you. You can start sharing your screen, Fatma.
Okay.
Go ahead. Fatma.
Okay. There she is again. Okay.
Fatma is going and coming back.
Okay, can you try to share your screen? Okay, it's coming. Okay.
Can you see my presentation?
No.
Just a moment.
Okay. Right
Can you
now,
see my presentation?
Yes.
Okay, first of all, I would like to ask something. So now you see only the presentation or the next slides? There are lots of echoes. I can't hear anything.
We see your first slide, Fatma. So you can put it into presentation mode right now.
Okay.
Okay, Fatma, you can start. As you explain it, please tell us at which slide you are in so that we can follow, okay?
Sorry?
When you present it, tell us which slide that you are at.
Okay.
Like second slide, third slide, so that we know that you are moving forward, all right?
Okay.
So you can start, please.
So can you see my main page right now?
Yes.
Okay. So I would like to present you our article about bank account transaction type prediction, which is called an approach to business workflow software architectures, a case study for bank account transaction type prediction. So I will go through these contents respectively. So in our study, our main objective is to design and develop a business workflow to predict bank account transaction types. And our main reason to conduct this study is you can see some bank account transactions in your individual user level applications in some banking applications, such categories like grocery, marketing, clothing, etc. But when it comes to accounting systems of big enterprises, it is such a difficulty to categorize those kind of transactions. For example, some spatial. Sorry, I'm so excited. That's why I'm just confusing. Such as some special transaction that a big company makes, such special expenses that they conduct. That's why we thought that this would be a great solution for this kind of problems. And when we tried to find out some related works, we couldn't find any specific solution for this problem. So we have searched for some similar studies about financial transaction data, such as short text classification on banking transaction and financial transaction classification. But all of them were not conducted in accounting data.
Fatma, I'm sorry for interrupting. I only see slide number 1. Is it just me or?
Me too.
Isn't
me
it
too,
in
yeah.
number 2?
No, so we are seeing the first slide. Maybe
sorry.
can you stop sharing and reshare again? It could be related with the way that you share. Are you sharing the whole screen?
I'm sharing only the conference slides.
Can you please share the whole screen, not the PowerPoint slides, the whole screen?
Okay. Can you see the presentation now?
Yeah.
Yes, perfect.
Okay, so
now you are at related work, right?
yes,
Okay.
in the second section.
Please continue.
So I will go over the related works. When we go for literature review for our study, we couldn't find any solution for our problem about the bank account transaction classification for accounting data. So we thought that it would be significant to search for other financial transaction analysis studies or some short text classification of banking transaction descriptions. And we found some significant solutions for our problems, but none of them were using transaction data for accounting for big enterprises. So we have used the significant algorithms from those studies and applied to our data for transaction for accounting field. So can you see the third slide?
Yeah.
Okay. So we conducted a system architecture for better comprehension. First of all, we take the raw data from HOSM Information Technologies, the company that provided our data set. And after this step, our data was really noisy, and we tried to clean all of the noise, such as punctuations, and we convert all of the upper cases to lower cases. And actually, the main problem was that our data was in Turkish. So we tried to convert the Turkish letters into English letters. So after this step, we have used bag of words embedding methods and word-back embedding methods to create new data sets to train our classification models. And we also had some model for category label construction to unify our categories to classify our data correctly. And after the deep learning and machine learning trainings, we sorry, I'm hearing some noise. After the deep learning and machine learning training, we also thought that it would be really useful to conduct an experimental study using association rule mining algorithms, such as epigrowth and a priori. In this study, we have used epigrowth algorithm. And to introduce our data, we have 100,000 bank transactions with description and category name columns. Our data also had some other features, other columns that contain some significant values, but it was the best to use the description column to do some word embeddings and classify our data better and correctly, because the other columns were really banks, how can I say, they were unique to banks, some different banks. So after taking data, we have used those data cleaning steps, uppercase to lowercase conversion, and Turkish letters to English letters conversion. We have cleaned all of the punctuation except the white space, and also in our categories, those categories are also our classes. With multi-word category names, we try to convert them into single words by with concatenating by underscore. And for the word embedding, we use n-gram word embedding and word-to-vec word embedding. But before word embedding step, we thought that it would be best to delete low frequency words from our data because they were creating some sort of noise in our classification and embedding. That's why we calculated all of the word frequencies and deleted low frequency words below the threshold. We took the threshold 3, but it can be changed in different situations. So in n-gram word embedding, we have used this embedding method because it was the best fit for our data. Because when it comes to description, some banks have some letter boundaries, and when you try to send a description from EFT from account B, but due to these boundaries, you cannot send all of the transaction description. So due to this problem, we have used this kind of n-gram word embedding. We took the embedding from the starting till the beginning by taking all of the combination again, starting from the beginning and to the end. So for the word-to-vec embedding, we have used 2 different types of word-to-vec embedding. First is average embedding, and second is weighted embedding. With the average embedding, we created 128 size vectors for each word, and we took the average of these words to create a unique 128 size of feature. And for the weighted word-to-vec, we also considered their word frequencies as a weight, and after that we applied average again. In machine learning methodology, we use support vector machines and random forest because in different studies, it has shown that those algorithms gave the best result for transaction data. That's why we applied SVM and RF for our study. And we used 2 different feature vectors for this classification methods. Weighted word-to-vec and average word-to-vec, and we split our data into train and test sets with the ratio of 80% and 20% respectively. As a deep learning method, we considered using long short-term memory would be the best fit for our data because it is one of the best for analyzing and classifying and predicting also the sequential data. So we use both of the word-to-vec embedding methods and also n-gram word embeddings because LSTM and n-gram gave the best results for different bank account transaction prediction problems. So again, we split our data into train and test sets with 8% and 20% ratios. And As an experimental study, we use frequency pattern growth algorithm with the support and confidence values set as 0.01 and 0.6 respectively. We have selected those support and confidence values because when we conduct research, when we conduct some trials about some different support and confidence values, those gave the best results for our data and for our rule set. And again, we also split our data into train and test sets 80% and 20% ratios. So our experiments shows that for machine learning algorithms shows that the average SVM gives the best results for machine learning algorithms. And if we try to analyze that, analyze the difference between weighted and average Word-to-Vec, weighted Word-to-Vec works better with random forest algorithm, and average Word-to-Vec works best with SVM algorithm. But still, average SVM gives the highest score for machine learning algorithms by 75%. And conducting deep learning algorithm, we have the test results of 82.9 with the highest scores for our study, and Ngram LSTM is the most successful algorithm that we used for our study. And as we can see, weighted LSTM gives us 73.2, and average LSTM gives the 76% accuracy for our study. But still, overall, all of our machine learning and deep learning results, Ngram LSTM gives the best result for our data. And as an experimental study, epigraph algorithm tries to assign some categories to some predefined rule sets. And when we try to test our data with the training rule sets, we see that our epigraph algorithm couldn't assign 43% of our data to any category. But we see that half and a half, it can classify our data, and it cannot classify data. But again, I'm mentioning this as a experimental study because in our future work, we plan to expand our category sets with association rule mining algorithms to lowest success assignments. So that's why we thought it would be the best to start this research by this study. So in conclusion, we see that it can be seen that LSTM deep learning algorithm gives a high score for our study, and we see that our workflow can be improved for some business problems that we mentioned before for accounting data in big enterprises. And we also see that epigraph and such different association rule mining algorithms can be used to predict new categories for our data. And we also see that there are some state-of-art embedding methods such as BERT and some different association rule mining algorithms. And we see that those can be used to improve our study for the future studies. So thank you for listening. I'm open to questions.
Yes, Fatma, thank you very much. Looks like it's very interesting research. I may have a couple of questions. One is if you could clarify, I didn't understand correctly. What is so specific about transaction categorization in accounting?
The specific part is that in accounting you have some how can I say, you have some different payments, like how can I say, I can mention one about that. For example, in the highways, you need to pay some fee in Turkey, and for this kind of fees, you have some special codes in the transaction data. So, for example, we try to catch those codes and try to classify them as HGS or some different codes. So those are some specific data for big enterprises, because they also have some separate accounting for those kind of expenses.
Okay, just to see what the point was.
I might
for this.
also add something to this question, if that's okay.
Yes, sure.
The majority of banking transactions, when person A is transferring money to person B, they write an explanation in the money transfer, and usually they put the keyword other. So even though one can write the exact category, for example, it's a rent or it's a payment for previous loan or something. So they usually pick the keyword other, and for the companies which receive these payments in high volume, they would like to categorize these incoming payments based on the description that is written in the explanations. And so what we try to do that, basically we try to model the incoming transactions from the explanations that are written in the transactions, and based on the models that are extracted from the transactions, we basically try to predict the type of the incoming transaction, which was important for the companies in order to understand what was the payment for.
Okay, well, that clarifies the question. Thank you both. If I may ask another little more technical question. I remember on slide number 5, when it was a framework, or 11 in conclusions, you mentioned that you have results from experimenting with both random forest and SVM, for example, but also not sure, did you use some kind of ensemble voting, or it's two different modules?
Sorry?
Was it two different separate modules of the same system, or it was two different solutions with random forest and support vector machines, for example? Was it a comparative study, or it includes?
It was a comparative study. We wanted to try which model provides a better prediction, and those two were the representative for the classical machine learning algorithms, and for the deep learning approaches, we use LSTM-based approach.
Okay, so it was not an ensemble voting. I wanted just to make it clear for myself. And out of curiosity, in SVM, did you play with different kernels, and which one was the winner?
That we did not try. So we basically went for the existing configuration that was available out of.
Okay, so use default settings.
Exactly. Yes.
That's usually, usually it works with 95%. So that's a good choice. As I said, it was just curiosity. Thank you very much. Very nice presentation. Very interesting work. Very specific. I'm happy I got to know something new.
Thank you.
Thank you.
Thank
Good
you.
luck with the
Thank you,
future work.
Ruslan. This is a nice time to see you all, Fatma, Mehmet together. And I was expecting Mehmet to come here this time, because it is now we are free from Corona and Turkey is not away, right? Mehmet, why you have not come this time?
Well, so I'm really ashamed not to be there, but I contributed with a lot of papers to this conference with most of my students. We showed great presence in the whole conference, I really wanted to be there, but since I have managerial duties at the university, and so this is the end of the semester here.
I understand, Mehmet, okay? But I want to see you. You should
So
take the
because of
Fatima
that, so but I really want
beautiful
to be there.
Turkish lady here, right? So my ICCA guys, they can also enjoy Fatima and your other Turkish beauties, right? So she is online. Nobody can do anything. It's okay. It is very nice.
Yes.
I hope that Mehmet and Ruslan as well. Next year we are meeting together, right? Anywhere we are going,
Yes.
you both are invited. Fatma, you are also invited if you continue your PhD. Thank you so much.
Thank you.
Just
Thank
for
you,
a quick
Mr. Thank
note,
you.
if you have a very good, because this presentation was something with the architecture and there is some novelty and you can extend up to the 75%, then you can check on the MDPI software engineering applications. And I have 5 generals, that is the applied sciences with impact factor 2.7, 2.8. Other one is electronics. Just to select software engineering applications, inform me earlier. I can give you full discount or half something. I will try my best. We have some. I am editor-in-chief of that software engineering applications in MDPI for the 5 journals. 2 of them is in SCI journals with the impact factor to around 3. So for all the authors, you can try this one. We have other journals as well. Just we concluded a NASA journal from Springer, but we have also selected some papers from some of the authors. So, but we have other opportunities. So just to contact with me. But if you have some solid papers and you can change your papers, which is submitted to software engineering, means SEPA, SSQM, TDSDP, 75% change, just to contact me, Mehmet, right? I can send it down your
Okay.
one paper.
Yes,
Right?
yes, yes.
From the German authors, yes, you can also do the same thing. And I also invited one from the Poland, if they are agreed. Otherwise, for today, thank you so much. Tomorrow, Software Quality Symposium is in the morning. International Symposium on Software Quality. Mehmet, with your students, please join. Ruslan, thank you so much.
Thank you,
Thank you.
Sanjay. It was
Okay.
very interesting session. Happy
Yeah,
to
I
be
can
here.
assure you one thing, that you are in the best place in the world, Ruslan. Too hot. Really, believe me, 33 degrees centigrade in Madrid and this Malaga. And in Halden it is 21, 22, right? So still you are
Come
in a
back
very,
to Norway. Come back to Norway, Sanjay.
I'm coming back very soon, right?
It's
Thank you
very
so much.
comfortable
Okay,
temperature.
okay, good. So it is okay. Have a nice evening to everybody. See you tomorrow.
Thank you. Bye-bye.
Thank you
you.
so much.
Bye.
Bye-bye, Fatima.
Bye.
See you next year. So thank you, my audience, right? Today.